Exercise has long been known to be good for not only general well-being but also for the brain. Now, previous research has looked into the effects of more sustained workouts of, say, 30 to 40 minutes on things like improving memory and also on learning. Now there's some new research looking into the effects of short bursts of exercise on brain power. Now, this research mainly looking at 7 to 13-year-olds. Joining me on the show this morning is the University of Auckland researcher David Moreau from the School of Psychology. Hi, David. Thanks so much for joining us today.
Good morning, Diane. My pleasure.
Firstly, tell us about this research. What did it involve?
So here's the idea. We implemented for 6 weeks a training program that was based on high-intensity training. So that's what's called HIT. And the idea really was short burst of exercise in the classroom, taking just 10 minutes per day. And we decided to look at the effect of this type of exercise on the brain. So we had what we call a pre-test, post-test design, which means that we looked at measures of cognitive abilities at baseline, and then we implemented that training program over six weeks. And we came back to those schools after the 6 weeks to look at improvements. And what we found is that this is actually a very interesting way to enhance cognitive ability, so to enhance brain function. And an interesting way that's potentially as good as longer forms of exercise, and that is definitely better than an active control group that was the comparison in this case.
So what results were you seeing exactly in the children that took part in this and were doing this short bursts of training? What sort of things were you seeing in terms of their learning?
Right. So multiple things, really. The main outcomes were working memory capacity and cognitive control. Now, those two things, all the listeners might not be familiar with those ideas, those constructs. And so the idea is that working memory is your capacity to hold information in your mind at any point in time. So at school, we can see how this is very important. Because this means that a child is going to be able to maintain more information at any point in time and to do more with that information. So I can retain more knowledge and I can use more of that knowledge to solve a particular problem that I have at a given point in time. Now, when it comes to cognitive control, this is pretty much what we, in colloquial terms, call attention. So the capacity for those kids to pay attention to the learning content in this case. And so we saw enhancement and some improvements in that as well. Working memory, capacity, and attention pretty much. In addition to that, we also saw important physiological improvements. So those children were getting healthier throughout the program, and we could see that with measures of resting heart rate, for example, for which we know that to some extent the lower the better, so the lower the healthier in this case. And so we saw improvements across the board in some brain measures and physiological measures as well.
So if this was to be implemented in a classroom, what would this look like in a day? Would kids sort of every so often just get up and have a little run around the school? Or what does something like this look like?
Right. So the way it was implemented was actually in the classroom. All we had was a video-based workout, just like a kind of workout that you could find on YouTube, for example, that was projected on a large screen. And so kids were pushing chairs and tables around just to have some space there to move. And those movements are pretty easy and fairly static. So just to give you an example, we do things like jumping jacks, for example, or some high jumps or things like that, just staying in one place. And so what that means is that we can actually stay in the classroom because it's just 10 minutes. we can also make sure that we don't need to go to the gym or outside for anything like that. Kids don't actually get sweaty in just 10 minutes. So that's fairly easy to implement and fairly convenient. Now, in the program, we implemented that for every day of the week, so 5 days a week. But in the future, once this has been released and once we have that available to schools, there's nothing that prevents them from implementing that, say, 3 times a week, for example, or twice a week if they don't have the possibility to implement that every day.
Mm-mm. So it wouldn't be sort of every hour the kids get up and have a jump and then sit back down. It's perhaps just a once a day thing within their learning, within a stretch of learning.
Right. It's possible as well, right? We could implement that more than once a day. Now, it's fairly exhausting, actually, the way it's implemented. It doesn't seem like that, right? You're thinking 10 minutes per day, 10 minutes of exercise, can probably do that, a couple of times or at least 3 times throughout the day. But it turns out, really, by the time we get to the next day and they get to do that workout again, they've barely recovered from what was there the day before. And that's the key here, right? In that kind of exercise, high intensity training, the key is the intensity. So if the kids are not playing along and they're not really giving it 100%, then the kind of outcomes that we see are not quite the ones that we've observed in our study. So it's really important at that point that they give it 100% and that they give it everything they've got. And what that means is that then it's going to take a little while before they can do that again. And if we implement too many of those sessions throughout the day, what we typically have is that there's some kind of decrease in intensity, and then we might not actually be doing any good anymore. So not necessarily more than once a day, but once a day, 5 days a week is a pretty good schedule for that kind of exercise.
Now, I was reading that this is also perhaps beneficial for children who have learning difficulties or even conditions such as autism. How is that? How does that work?
Right. So in that study, we did not find any kind of difference between kids that haven't been diagnosed with any kind of learning disorder or learning disability and the others. Now, typically what we'd see is that anyone who's lower on any kind of a measure, brain measure at baseline is more likely to improve with this kind of exercise. And that's typically what happens with kids that might have, say, dyslexia, ADHD, or any other kind of learning disability. What we typically see is that there's more room for improvement in a way. So the exercise regimen is more likely to benefit them than it is to benefit someone who's already doing really, really well on those measures of cognition.
Hey, thank you so much for joining us today, David. It'll be interesting to see what the classrooms of the future look like and perhaps if something like this is going to be implemented. Thank you, David. It's lovely to have you on the show.
Thanks for having me.